You now have a class inside of your project. Let's examine its structure closely. As you've noticed, the class lives inside of a namespace. This allows your class to be referenced by other classes via a using statement. By default, the namespace is the name of your project, but you can always change it. However, keeping namespaces the same as the project names is a commonly used convention. In this particular example, we have one using statement on the first line. By doing so, we are gaining access to classes from within the system namespace. Note how both the namespace and the class open and close in curly brackets. In C# and in many other C family languages for that matter, those outline boundaries of some structure or piece of functionality. Inside the class, you have variables make, model, top speed, and date created. These are used as memory placeholders for storing your data when the program runs. What is really important to know is that each of these variables can only store a particular data type. So, in our example, we can change the values of make and model fields from what they initially are. However, we can only change those to textual values enclosed in double quotes. In C#, this textual data type is known as a string, as indicated by the keyword used before the variable name. Top speed variable holds a numeric data type known as int. This stores whole numeric values without a decimal point. There are also other numeric data types that can store values containing a decimal point. Float, double, and decimal are examples of those in C#. Likewise, int is not the only data type that holds an integral numeric value. There are also short and long, which differ only in the amount of memory they use and hence the maximum values they can store. For each one of those, there is also an unsigned variety, which has the same name but starts with the letter U. So you have uShort, uInt, and uLong. Those cannot store negative values. However, the maximum positive value that each of those can store is double of what can be stored in its standard counterpart. Date created is an example of a variable that stores a struct called datetime. This variable is only restricted to this type of struct. Finally, an instance of our own class can be created and stored in a variable elsewhere. This will be demonstrated later. As well as having fields in the class, you also have three methods: getMake, getTopSpeed, and adjustTopSpeed. Those can be accessed by other places in the code to execute some piece of logic inside your class. Accessing those methods from elsewhere is referred to as calling methods. You have probably noticed that, unlike fields, methods have brackets after their names. Those are used to pass input parameters into each method. If the brackets are empty, the method doesn't accept any parameters. We have now outlined a basic structure of a class. However, our class is useless unless we can refer to it from a running program. Therefore, please follow this instruction to set up an entry point into your program.